Have you ever heard of even or odd functions? Let's start first with this even function, f of x equals x squared. An even function is symmetric about the y-axis, as we see here. In math talk, we can say a function y equals f of x is even if for each x in the domain of f of negative x equals f of x. What does this mean? This means that when we have an even function, it doesn't matter if we plug in a positive number or the negative of that same number. Both numbers, the positive and the negative of that same number, give us the same output. For example, when we plug in a 1, we get a 1 as an output. And when we plug in a negative 1, we also get a 1 as an output. Or when we plug in, for example, a 2, we get a 4 as an output, and when we plug in a negative 2, we also get a 4 as an output. Let's prove algebraically that this function is even. To prove that this function is even, we have to show that f of negative x equals f of x for each x in the domain. We know that f of x equals x squared. So the only thing we have to show is that f of negative x equals x squared. Then we have shown that f of negative x equals f of x. If f of x equals x squared, then f of negative x equals negative x in parentheses squared. If you don't see that, I highly recommend watching some of my previous videos evaluating functions. Now, instead of negative x in parentheses squared, we can also write x squared. Because when we square a number, the result is always positive. In other words, negative x in parentheses squared is equivalent to x squared. And x squared is equal to f of x. In other words, we have shown algebraically that f of x equals x squared is an even function. Let's look at the odd function f of x equals x cubed minus 3x. Odd functions are symmetric about the origin, as we see in this graph. In math talk, we can say a function y equals f of x is odd if for each x in the domain of f of negative x equals the negative of f of x. What does this mean? This means that when we have an odd function, the negative of each f of x is symmetric about the y-axis. For example, when we look at the negative of f of 1, which is 2, we see that the point 1, 2 is symmetric about the y-axis. Or when we look at, for example, the negative of f of 2, which is negative 4, we see that the point 2, negative 4 is symmetric about the y-axis. Let's prove algebraically that this function is odd. To prove that this function is odd, we have to show that f of negative x equals the negative of f of x. So let's start with f of negative x. f of negative x equals negative x in parentheses cubed minus 3 times negative x. We can remove the parentheses because negative x in parentheses cubed is equivalent to negative x cubed. Do you know why? I really encourage you to think about it and write your answer in the comments. And negative 3 times negative x is 3x. So we get negative x cubed plus 3x, which we can write as negative x cubed minus 3x, which is equivalent to negative f of x. So we have shown that f of negative x equals the negative of f of x. In other words, we have shown algebraically that f of x equals x cubed minus 3x is an odd function. If you like my videos, like, share and subscribe. Thanks for watching and happy learning, everyone.